This is the worked answers to the Unit 8 test. This is question 5. So in this question, it looks quite long. It's worth 15 marks, so it should take around 15 minutes. We have a box of 0.8 kilograms called A, is on a rough horizontal table, and is attached to one end of a light inextendable string. The string passed over a smooth pulley fixed at the edge of the table. The other end of the string is attached to sphere B of mass 1.2 kilograms, which hangs freely below the pulley. Okay, that's quite a lot of information, so I'm just going to draw what we know so far. So we have our table, we have box A. Box A is 0.8 kilograms. That's going off a table and is attached to a box which is 1.2 kilograms. I was told that it is a rough table, so there's going to be some sort of force going this way due to the friction. There's going to be a weight force caused by this hanging freely of 1.2 G. This rope and this particle is going to cause this one to want to be pulled this way, which is T, but this one is slowing this one down, so it's pulling this one backwards, again, T. So it's consistent all the way through. That's what we're being told so far. The magnitude of frictional force between A and a table is F, so I can add an F to here. The system is released from rest, with the string being taut after release. B descends 0.9 meters in 0.8 seconds. So it hits the floor, so that this distance here is 0.9 meters, and this happens in 0.8 seconds. We are asked to find the acceleration of B, the tension in the string, the value of F. So from the picture we probably could have gathered that due to the fact we have two unknowns. So in fact they've actually been quite helpful by telling you to work out the acceleration. So I'm given a time and a distance. So that's spring to mind. I'm trying to work out acceleration. The displacement, 0.9. The starting velocity is 0. I don't know the final velocity. Acceleration is unknown, that's what we're trying to find, but I do know time, which is 0.8. So a link between S, U, A and T, I've got S equals UT plus a half AT squared. So I have 0.9 equals 0, a half of AT squared. So a half of A 0.8 squared. Times by 2 and divide by this squared. So 1.8 divided by 0.64 will give me the acceleration. Usually these tend to be quite nice numbers, but in this case it's not. The acceleration is 45 over 16. I wouldn't use rounded answers purely because you'll get rounding errors all the way through, so we do want to use this exact answer. Part B asks us to find the tension of T. I am going to split the model up, and I could use this particle or this particle. The problem with using this particle is we still have two unknowns, so I'm going to have to work with this one. So we have our box of 1.2 kilograms. I have a force coming down of 1.2 G. I have the upwards force, which is the tension, but I've just worked out in the previous question it is accelerating in this direction 45 over 16. Using F equals ma, this force is clearly bigger than this force because it's accelerating down, so 1.2 G minus T equals ma, so equals 1.2 45 over 16. Rearranging this, 1.2 G minus 1.2 45 over 16 equals T. Type this into our calculator and we get T equals 8.385. Tension is measured in newtons, so that is our final answer for parts A and parts B. Part C wants you to work out F, So I'm clearly now going to have to use this thing, but what I can now do is just look at particle A. So this is 0.8 kilograms. There's a force this way, which is caused by the tension. There's a force this way, which is caused by friction. We know that it's going to be accelerating in this direction, so that means it must be accelerating that way. Acceleration is 45/16, because the acceleration of the whole system is the same because the string was taut. This one must be bigger than that one so that it can move that way, so T minus F equals 45/16 times 0.8. Rearrange this to make F the subject. F equals T minus 45/16 times 0.8. Substitute our value of T in here and type that into a calculator, and we're going to get that F equals 8.385 minus, that was just 8/10, so that's 16, 8/10, that cancel. F equals 6.135 newtons. And if I had a calculator to hand, I'd work this out, but I'm not going to bother.